everybody. Thank you for coming to Prod.js, to our September meetup. I'm going to keep the introduction short tonight. We're talking about ES, Infinity, and beyond, Bulletproof JavaScript, and we have Owen Buckley, Director of Engineering at Kenzan.
Thank you. Can you guys hear me all right? Should I move this up? Good? All right. Awesome. Well, thanks for coming down. It's my first time here, so nice to meet all of you. I will be discussing JavaScript, as the title might imply, looking at ES6, TypeScript, and beyond, and some use cases and new techniques, APIs, and all the new good stuff that's coming to the browser near you. So just a little bit about Kenzan. Our office is in Pawtucket. We also have offices in New York and Rhode Island and Los Angeles. We initially started off working in ITV, interactive television applications and websites, and grew into platform as a service, doing cloud virtualization, DevOps, and basically PMBA, and running the entire gamut of the application lifecycle. And then there's a few of our clients down there. And as Tim said, I'm a director of engineering. I started way in the beginning doing the ITV apps and worked all the way up with these guys and went along for the ride. So here, I'll just give a brief overview of what we'll discuss. So I'll just kind of give an introduction of the presentation. We'll look at some language constructs in ES6 and TypeScript. Discuss dependency management, module loading. I have some repos and some code samples to show you. And as with any tool, it's knowing the pros and the cons, so we'll kind of go over that. And then there'll be definitely, hopefully, plenty of time for questions. Is there like a time limit I should try and keep myself to? Okay, awesome, cool. Well, I will jump right in then. So JavaScript today. Not sure how many of you are actively writing JavaScript every day. Show of hands, I guess. How many of you are writing? Awesome, awesome. And are any of you writing ES6 or TypeScript today? Nice, awesome, great. Are the others familiar or aware of it, and just maybe it's just on your radar, but just not in the, cool, awesome. Well, for a lot of us who've been writing JavaScript for a number of years, we're probably all quite familiar, and even those who work on projects that have front-end components are probably familiar with how large UI applications are getting these days. There's browsers in particular are getting a lot better, rendering the DOM, being able to do more complex tasks, local storage, web workers, Canvas, all that stuff is now in the browser, and as a result, it's natural that application developers, product teams would want to push and get their applications to do as much as possible. And so as a result, as applications needs get bigger, the desire to manage those frameworks like Angular, UI libraries like React, all the ecosystems around them have sprung up to really try and support developers in managing the complexity and oftentimes the craziness that goes into managing really large scale applications. And as a result, a lot of patterns have emerged over the course of development in the past 5-10 years. And we're seeing these similar patterns like in object creation and instantiation, and trying to either work around prototypes or work with prototypes and all that good stuff. So the complexity is increasing. Developers are kind of coalescing around patterns, a lot of them influenced from more classic, strictly typed languages. And so the governing body has responded to that. So we see, in the what's commonly referred to as syntax sugar. So we now start seeing the introduction of concepts like classes, and we see imports and exports like packages in Java, and constants, things that we kind of had to maybe duck type or mimic in ES5 and lower. We've now seen the patterns so widespread and so commonly used that they've now started to make their way into the language specification itself. Similar in fashion to how the W3C, when they drafted HTML5, they actually scanned web pages and found that the most common IDs that people were using on divs were header, nav, footer, and then those just became new HTML elements. So the governing body is responding to the patterns that are emerging, and so now we have these kind of familiar concepts. And from a perspective of being a developer and being a maintainer, having good terminology, equal footing, there's a way to express a class versus the myriad ways that people have done it before. And so now we're kind of getting into a position where we can see JavaScript as starting to really stabilize and really come into its own and provide a lot of tooling. I would probably say one of the the biggest advances to really drive this, in my opinion, is imports and exports, and dealing with and using packages, using tools like Webpack, Rollup. You can really get into some really interesting bundle and module loading techniques that really optimize your applications, especially in the context of a single page application where you kind of tend to have to front load a decent amount of your JavaScript to deliver that initial payload, get the screen up and rendering, and then from that point forward the user's experience is fairly snappy. In general, I have no skin in the game when it comes to use Angular or use React or Aurelia or anything like that. I've had experience. I have at least experience with React and Angular. I've looked into all the other frameworks. They all have their pros and cons. For me, the principled stand is on the actual specification itself. Are these languages, are these tools going to adopt the standards that will eventually be part of the language itself, right? For the time being, you'll use polyfills and you use shims, but what you really want is an application built on, if you're going to use them, ideally they're going to be things that will just eventually go away because SystemJS will be supported by browsers. Imports and classes will be supported by browsers. You're not kind of lugging around CoffeeScript for the rest of your life. And of course, for me, in addition to the coalescing, it's the readability, the consistency, the clarity. Going back and just seeing code that looks the same everywhere else in your application because everyone's just going to use a class now instead of prototypes or ifs and all that, all those flavors and permutations. So we'll go over, like I said, we'll go over the language construct. So we'll talk about ES6 Typescript, dependency management. So two good tools these days are npm and JSPM. I'm not sure how many of you use Bower, but that's kind of on its way out. That has nothing to do with being standards compliant or not, in so much as that support for imports and being able to use common JS and transpile that means that you can pretty much just get anything you want off of npm. And for any developer, at least someone like myself who helps design and maintain builds and all that, less tools, the better. And then for module bundling and loading, I have recently come into favor with Webpack. I've been using it. In particular, what caught my eye was that in the 2.0 version, they're going to start supporting SystemJS and imports, which for me is, was what I was waiting for in a tool like that. And then, of course, SystemJS being an ES7 polyfill to actually load your application into the browser. So it'll be system will actually be the global variable. So that kind of gives you an idea of, I guess, the stack that I'll be talking about and that I've had some good success and experience with. So I will start off by just kind of discussing the language changes that are coming. So we'll take something, say, trivial like representing a constant, which is a value that we don't want to change. When we assign its value once, we want it to stay that way. In JavaScript pre-ES5, there's really no good way to do that. You can kind of work your way around it. Just put it in capital letters. Sure, whatever. That works, right? Exactly. Really, none of these work, and sometimes you really just want a constant. Well, simple. Now you just get a constant, right? So, I'm just starting off with something small, but you kind of get the idea when you want safety, when you want that assurance of, the value that you set will be there all the way through the final cycle of your runtime, then you're good to go. So that's start off small. We'll take a look. So you may or may not have heard of what is referred to as fat arrow functions in JavaScript. Well, that one actually doesn't quite have it. I forgot the parentheses. But the next example, I think, will illustrate it a little bit better. So there's now a technique in JavaScript where you can just use the parentheses that would normally come after the function keyword. And in addition to being a little more terse, it has the really awesome ability to preserve the local, the current scope, right? So this might be familiar. We're using callback functions. We want to set a property in our class, in our object, whatever it is. Well, when we execute within the context of make Ajax request, this refers to this function right here, not the class. And so we've often had to work around it by making a reference to this and then assigning the property within that. Well, now we can use the fat arrow function, and we can just basically, this will be preserved for us. So we have the ability now to kind of clean things up. And so this is kind of where I'm trying to go with kind of what, aside from just the syntax sugar, the new spec provides. We're looking at ways to clean up our code and make things readable and consistent. And so from so now some people call it self, some people call it that. Well, you don't even have to have that debate anymore. You don't have to worry that more than in one part of the code you're using this, in one part you're using that. You just have a construct that's just what you use now. So. So another big one is classes. There's at least a couple of the more popular ways to create classes in JavaScript. Well, now you just have class, and that's the keyword that you use, and that represents generally what we've been trying to do here. In addition, one of the really nice additions is now there's the concept of a constructor, which a lot of us would maybe do with an iffy here, or we call it init and we call it later on. Well, again, now that kind of inconsistency that I like init, I like, just immediately invoke function. Well, now you just use constructor, right? And so you're kind of seeing how we get to focus more on the code we write and less of the little preferences for how we write it. That's not to say that, it makes the language boring or dull. It just, it just makes it, just provides kind of a more consistent, equal footing for everyone that, well, now there's an actual keyword or a construct that you use instead of what we were, maybe trying to work around before. So that was kind of a little intro to ES6. I'll talk about TypeScript. Essentially, TypeScript is a superset of JavaScript, and as the name implies, its major benefit or value add is a type system to JavaScript. So for those of you who might not be familiar with what a type might be, a lot of languages have the concept of primitives, like say int, string, bool, and in a language like Java, you would have to declare the type of your variable, and from that point forward, for the most part, if it starts off a number, then it's going to show a compiler error if you assign it to, say, a string. And so that's kind of essentially what TypeScript looks to support. And so it will then has a compiler, which will then compile to a number of targets like ES3, 5, or even 6 if that's your intended target. And so it also allows you to create definitions within your own project. So if you have the concept of a user that has an ID and a name and an age, you can define that, and you can define which of those properties are required, which ones are optional, and then that type, you can reference that type throughout your application and be assured that anytime you're interacting with the user object, that it'll have the properties and the methods that you expect, and kind of getting away from what's referred to as duck typing. Well, if it has this property, it has this method, then it should be this, or that's all I care about. But sometimes we prefer a little bit more confidence. And the additional benefit of using TypeScript is that the TypeScript language and the compiler will continue to support newer JavaScript features. So ES7 features and the like will be supported. So similar to how Babel, which is a transpiler, will transpile JavaScript and has support, you'll get the same thing from TypeScript. So you don't have to really worry that you're missing out. Like, I'm not ever going to be able to use SystemJS. TypeScript's very committed to keeping up with the language, as well as contributing to it. They can try out experimental features, see if the community likes it, and maybe it can make its way into the specification. And being a superset, you do have to transpile it. And the advantage here is now you can do a lot more debugging in your terminal instead of waiting for the browser to refresh. So the compiler becomes a source of instant feedback. And so you can see the impacts to your code immediately without having to, say, walk through a form or your sign-in process or whatever. Or if you do, you know that all the little things like that you deleted something or renamed something will get caught. Sorry, was there a question in the back?
Yeah, so I assume you still can write plain vanilla JavaScript?
Yes, absolutely. You could run the compiler against all your JavaScript code and it'll still be fine. Yep, absolutely. Good question. Yeah, because really at the end of the day, it's just JavaScript still. more or less. So we'll take a quick look at an example. So here's a simple function that just says, hello, whatever name you pass in. And as we can see, we suffix our variable with the colon and then the type. And now, if we were to say pass a number into this say my name function, then we would get a compiler error. So right away, so immediate use would be, say, if you're creating a service that interacts with the RESTful API, you require that someone passes in an ID to query all items in this set. Or you're creating a new user and the name has to be a string, the age has to be a number. Well, now you can enforce this through the compiler. You don't have to do if type of equals number and if this, that, and the other things. So you kind of can strip out a lot of that kind of validation boilerplate just through a type, adding a type to your function signature. And so here we kind of see an example of a class written in TypeScript, and now we're kind of getting into private and public. There's also protected as well. And then it still supports constructors, so it still just looks like the same class that we saw a couple slides ago. But now we can see that if we were to create a new instance of person and try to access the private name property, we would get a compiler error. So we just add a little more stability, security, and assuredness that by the time we get to the browser after doing our work, a lot of these small little things are out of the way and you really get to just focus on building your application and the features that you want to deliver. Instead of a small typo like, oh, I forgot the E, well now I got to go back, fix that, wait for my build to run and refresh the browser. You get that right away. It adds up over the course of a day. We also have interfaces. If you're familiar with those, it just basically kind of lets you define the structure of an object, similar to a class, but obviously you don't instantiate it. But it's really helpful for, say, in your service that makes a call to RESTful API. I like to use this example. If you return a list of users, you can then create an interface. In this case, the framework, so it's got an ID, it's got a name. You can now identify this collection as an array of these frameworks. And you know that if that's what you get, which you can use the type system to say, not only can I define an array of these framework objects, if I'm expecting that, I can also use this same type to say, I only expect an array of frameworks. And that way, you know that if this array passes the compiler check, that you know that each one of these is going to have an ID and it's going to have a name. That's it. You don't have to worry. The compiler is catching all that stuff for you. So that was a little bit about them. Yep.
Do types in TypeScript, can you extend to somebody else's? Like if you're bringing a library in for like networking and they have a really cool, I don't know, Sept API or something, would you want to add a method to one of their interfaces or classes to do that?
I don't see why you couldn't. So all these types are defined in what's called a type definition file, and there's a repository on GitHub that stores them all. So you can install them locally. It also has a command line interface called typings, and so you use that like you would say npm install Angular. You could do typings install Angular, and you could get type definitions for it. And so with that, you could then either fork it if you wanted to maintain it. Can you do it at compile time? That I don't know. Like if you included a script and then you say polyfilled something that was included, and then the rest of your application, like for instance, wrapping an HTTP object to say always attach a bearer token on every outgoing request, right? Can you decorate it in that way? I don't know, I haven't tried. But the definitions are just text files, so there's no reason you couldn't just copy that, make the edits you want, and run with that too. So we'll talk a little bit about dependency management. Pretty much a lot of projects, so I don't think I've worked on a project without one. At least some dependencies, at least any big project. So I would normally give a nod to Bower, but I just don't know if it's going to be relevant much longer. Not to say that it was definitely a bad tool at all, and still actively use it in a lot of projects. However, maintenance on the project has slowed, so that in and of itself is a consideration. But basically now where NPM is pretty much at the top, I've seen a lot of convergence on it. A lot of front-end applications are publishing to it. It's all just JavaScript, so at the end of the day, you're just getting files from one directory instead of another. But since you're also likely pulling in all your build tools and all that, might as well just trim the fat. One thing that was prior to things like Webpack and kind of the imports, it was a lot harder to be able to kind of give your give a SystemJS like your entry file, and from there it could read all the imports and build something up from that. That wasn't always available, so it was nice to have a Bower where these are all these are all my dependencies for the browser. These are all my dependencies for my build, and then they had really good tools around that where a tool could just read all the dependencies in your bower.json and slap all the script tags into the document for you. But with imports and tools like Webpack and JSPM that can create a dependency graph for you, they're only going to pull in whatever you import. So you never have to worry about, well, if I move to NPM, how am I going to grab just the things I need? How do I make sure I don't include gulp in my project and only include, say, Axios for Ajax? That tooling is a lot better now, and to have one less dependency, especially a package manager for JavaScript when you already have one. Anyway, get where I'm going with that. JSPM is authored by the same developer who created SystemJS Polyfill. There's a JavaScript Polyfill for it in GitHub. And so the two work really well together. JSPM you could use in lieu of NPM, install your packages. It has a command line tool. It can create a dependency graph. That said, it's not a task runner. It's not a grunt or a gulp. It's not a Webpack. So while it does have value, just keep in mind that there might still be another tool or two you might need to use. So it does some things, but some people really like, I just want a package manager. I don't want anything else. I've got something else for that. Just keeps the overhead low. But either way, I've had obviously more experience with NPM. I think most people would, since JSPM is so new. But I have used JSPM in some in a project that I'll show you, and I didn't have any objections to it. But Webpack is, for example, really good at creating a good dependency graph and optimizing your bundle. So you'll have to keep that in mind and obviously profile. Yep.
One of the things I love about NPM is also the documentation.
Yes.
How does JSPM compare?
Well, I would say it's pretty good. Like I said, I haven't used it a lot. I've used it in a couple projects. I found that there wasn't much, I didn't have much friction. I mean, that's their tagline: frictionless package management. I used it before I used Webpack. I really liked it because it was all going to be based around ES6 and stuff like that. So that said, compared to a tool like Webpack, and like I'll get into later with Webpack 2 supporting imports, you really get a lot more bang for your buck. So, with any case, you kind of have to weigh the pros and the cons. Webpack's a lot harder to figure out, and SystemJS PM is just a few commands, and there's one command to create your bundle. So I haven't I wouldn't rule any of them out, but the documentation I found to be pretty good. So let's take an example. So this, depending on how you might have developed this, to me at one point in time was a best case scenario. I could use tools like inject and wire deps and have it analyze my bower.json in the case of wire deps, or the files in my build directory, and from there these tools would then insert the correct CSS and JavaScript script tags into the document. However, in a case like Angular, order is important, so it doesn't necessarily solve that problem, but at least there's tools to minimize the amount of kind of manual updating that you'd have to do like each time you add something. So this was good. Something like this is a lot better. So this is an example of SystemJS being used, right? So the first script tag is just the polyfill, in this case installed through, when I installed JSPM, SystemJS comes for free. The config file is essentially the dependency graph that JSPM maintains for you. So every time you'd write, you type JSPM install blah, it's going to save that into your package JSON if you want, and then it will maintain the versions and maintain all the dependencies around that, and it's basically going to, the config.js is basically just your dependency graph. You don't have to touch it. I don't, and it'll write automatically and update. You can use JSPM uninstall, it'll clean things out. But essentially, now all your dependencies are managed in one file. I mean, it doesn't copy them all in. It's just basically one big object that references all your dependencies, in your JSPM packages folder. And then basically, you just kick off your application. You find your entry point, and SystemJS takes over. It's going to follow all your import statements. It also works with CommonJS. And you can load CSS. I mean, you can load it in the browser. You can use JSPM to compile it. Your less or TypeScript ahead of time. For development, you can just transpile it on the fly in the browser. But we're kind of seeing that we have less and less maintenance to do, and the tools are doing that for us. And the most important thing here really is now order isn't important, right? Your dependencies are managed by JSPM as you install them, and you now just have to point to an entry file that will then load as needed everything for your application. So let's talk about module loading. So SystemJS is the future of module loading for JavaScript. It is a polyfill now. It didn't make it into ES6, but it is expected in ES7. So obviously you can use the SystemJS Polyfill off of GitHub, like I showed in the last slide. There's lots of tools that work with imports in SystemJS, but all of them will, if they are to maintain standards compliance, they will have to be relying on SystemJS. So that's pretty much the option there. I mean, you can use requires, you have a common JS, but that's not where JavaScript is going. So imports is where JavaScript is going. So align yourself with the tool that's going to be there for the next 5 years, and eventually not even in your tool chain anymore, because it'll just be in the browser. So here's a simple example of module loading. So we're just using import. So I'm importing an HTTP library, making some GET requests. As you can see here in this example, I'm actually importing CSS right into my application. The exclamation point is just to tell SystemJS that this is not a JavaScript file. So when it sees the exclamation point, it knows to process it as a CSS file, not JavaScript, which is the default. But anyway, this is just an example. And now you get a clearer idea when you go into your projects and into the files, what is actually needed by any given class or service or whatever framework you're using. And so rather than just having a bunch of imports in the head of your document that may or may not be used, may only be used by one thing, may not even be used anymore, but you forgot that it was there, you now have this explicitly, and IDEs are really good about graying out variables you don't use. They'll gray out imports that you don't use, so you can easily delete them. But what it's really getting to is being able to support tools that can smartly essentially crawl your application and build the best dependency graph for you, and basically be able to identify where there's duplication, get those out. So I would definitely, import has definitely been a really, for me, in my opinion anyway, a big player in JavaScript and pushing things forward. So here's kind of a stack, if you will. It's certainly not a end-all by any means, but this is just what I've been having good experience with. So obviously Node, NPM at the bottom. Obviously Webpack 2.0 will have it. We'll have SystemJS, and then at the top your favorite ES6 supported library or framework. But before we'd have a Bower, we might have Grunt, we might have Gulp, and we might have all the configuration that goes with it. But we're just really seeing a nice slim stacked column. In my eyes, I quite like that a lot. So I was going to show some sample code. Did anybody have any questions before I just jump into some GitHub repos? Yes. It really shouldn't be that hard. It naturally supports installing from GitHub or NPM, and it actually gives you the option to install right into your package.json, and you can basically set a key. It'll say, do you want to use JSPM as like the key for a new object of dependencies? And so you could, in theory, just install, let's say you're using jQuery, you could JSPM install it. It'll install it into package.json, that you could get rid of the other one. So you could kind of go one at a time if you wanted. But I mean, it's really just it's just pulling down JavaScript files, so it shouldn't be too much of a pain. I think what would be more of a concern is how are you getting those files into your browser? So that that might be a little bit different depending on how they come down through JSPM. So yes.
So is strong typing is mandatory as per ES6 specifications, or it is optional as per
That's part of
browsers?
the strong typing is part of TypeScript.
So it's not part of ES6?
No. To my knowledge, it hasn't been brought up for discussion as part of ES7 either. So the things that TypeScript can support that ES6 doesn't is like the concept of generators, which you see the annotation syntax in like Angular 2 with like @ component. And like async await, these are things that are in the spec that TypeScript can support. And then on top of that, it's, at the very top, it's adding the types and all that stuff. So the types are not part, like interface is not part. Class is part of the spec. The interface is not. Private, public is not. Constructor is, yep.
I also have one question
Mm-hmm.
regarding
Mm-hmm.
So does ES6 is still going to support a require or they are not going to?
Can I have both in my same project? We can coexist or we cannot?
So yeah, I mean, I don't think there would be a problem. I mean, require is the common JS specification, which is what NPM uses. So a tool like Webpack can understand require. So in your source code, you can require Axios, like say you would require gulp or something in like your gulp file. And then when you feed your entry point to Webpack, it'll understand those imports and it will probably transfile them or inject like the source code in. But require is not part of this ES6 specification or any specification. The actual that specification is imports instead. Imports are this, the specification version of requires. Mm-hmm. Mm-hmm.
With JSP, is it possible to design the lazy loading? Because what I saw in your other example is like you import a JSPM config.js,
Mm-hmm.
add your global HTML file
Mm-hmm.
and insert HTML. But in our case, we might have like bits of others of JavaScript and we do not want to get all the JavaScript because when you have a broad geographic application, getting those JavaScript can slow down user experience. I want to
Right.
easy loading how JSPM is going to handle the JavaScript.
So that config file isn't like a concatenation of all your dependencies. It's just an object file, and I can show you one in a second. It's just basically mapping the dependencies. Eventually, they'll actually have to be pulled out of Node or JSPM packages when the browser hits those import statements in your source code. And so basically, it's just a mapping. So when Axios is imported, SystemJS knows where in JSPM packages to find the index.js, if you will. So it's just being able to map the pretty name to like the actual location on the file system. So that's sure. So I have two little code samples of just little projects that I've worked on. And so, yep. So I guess just by show of hands, how many here have worked with React and Angular 1, 2? RC6 or RC7? Nice. All right. RC7 just came out though. So I have two examples. I'll just kind of walk through some of the highlights. So this is just a small little project that I made. For me, at times, working with certain clients who use GitHub and building a lot of component libraries, or even just managing some of the open source software for Kenzan, I found managing all the repositories was a little bit challenging. I created this. I'll just run it just so you can see it in action. But this uses React, SystemJS, JSPM, and TypeScript. And that's funny. Of course it worked right before I got here. Oh, I'm not connected to the network. That's probably why. I'll just get a hotspot up in a second, but. So, oh, nice, awesome, thank you. Okay, there we go. Awesome. All right. Well, oh, there we go. Now we got something going. So this just for me was just to be able to list repositories, and then basically if I was assigned anything, then it would light up. So it's just really just a test. It's nothing fancy, but I'll walk through the source code a little bit. So we'll start off with the, so here is the config file that I was talking about. So this is that file that JSPM manages for you. So when you like do install JSPM through npm and then do a JSPM init in your project, it'll walk you through just like a npm init would. And it's basically just, like I said, creating a map, literally, they call it, of your dependencies, and you can install from npm or GitHub, so it prefixes those. It's basically just finding, managing, mapping, a name to where it sits on the file system. So I mean, it's not super interesting. It's just basically, surprisingly for such a small application, this is all the stuff that it needs, but I never really have to look in here too much since it manages it for me. So my source, here's my package.json, and here are my JSPM dependencies managed for me. So you can optionally, you don't have to, it gives you the option to prefix it or not. It's totally up to you. And then this had most of the samples that I worked with. So I have some of my components. So here's, say here's the user details that shows my image. So I'm using React, but I'm using JSX, which more or less allows you to write kind of HTML into your JavaScript. Initially, I wasn't sure how I felt. It was a lot of discussion about whether or not HTML and JavaScript and CSS should ever really live in the same file, and everyone typically cited separation of concerns as the the reason why. Facebook responded and said, well, really what you're doing is a separation of technology. The real concern is having everything you need in one place. So it's definitely a different approach. I quite like it. What's really nice is if you have any sort of invalid HTML, it'll give you a compiler warning. So they do build a lot into the tooling. But you can see here I'm using let. Let is just a kind of a better bar. Most people recommend you only use let, but its scope only lasts in the current block that it's in. We're using const. You can see that in my component where I'm getting user details, I'm expecting the response I get to be of a type that I'd already defined called a GitHub user, which means that by the time I get in here, the last thing I'm worried about is whether or not avatar and username exist. So these are kind of some of the additional benefits that something like TypeScript will give you, and just kind of help you keep things consistent throughout your application. Now, be gentle. I haven't written a lot of React, so this is only my first application with it. And then we saw this index.html. Yep.
When you imported user details to CSS, there's a bang at the end. What does that mean?
Oh, right. Yep. So that's to tell the SystemJS that this is not a JavaScript file. By default, it will assume it's a JavaScript and add the .js for you. So by using the exclamation point, it'll be like, oh, no, this is a CSS file. And to that point, you do have to install like a CSS loader for SystemJS. It just doesn't, figure it out on its own. So yeah, so let me see if there's another decent example. Yeah, I just said this is basically just, I ignored a file that includes the credentials, so you just generate yourself a token and then put them in this get ignored file. So yeah, let me just quickly move on to the Angular 2 example. So similar layout. So this uses Angular 2 up to RC6 right now, Webpack, Node NPM, TypeScript, Karma, Jasmine, less Bootstrap. So this is kind of the other side of things. To give you an idea of what a Webpack build looks like compared to SystemJS. If you've ever used Grunt or Gulp, I like to think that, or I like to describe it as kind of being a little bit of column A and a little bit of column B. So you do have, these kind of familiar object kind of configurations. First, it's in your loaders, and then also in your plugins later on. But what's really interesting is, for example, this is a loader I made so I can load a less file in my Angular component styles URL, and Webpack will match against the file extension, and will then process that through this loader, and then I will have CSS in my transpiled output. So you can kind of think of the loader almost as like a Gulp pipeline, where I would compile my less, and then, or a better example would be JavaScript, where you would lint your JavaScript, then maybe concatenate it, then minify it in one pipeline. So that's kind of, to me, how I interpret the loaders to be. And so this is, for me, I kind of distilled it down from some of the examples that I saw to, there's a common loader, common config, which is generally just defining the loaders for all my different types of files. So my TypeScript, my less, my images, and HTML. I haven't quite, I have a few to-dos for myself. And then basically what it comes down to is there's a dev config. And this is essentially just going to take the common config and then just add a couple plugins that'll inject some environment variables. But mostly it just will start up a dev server. That's pretty much the big responsibility of the dev config. And then the production config takes that common config and will optimize the JavaScript. It will fail on TypeScript errors. and it'll handle loading the HTML. And then just to show you an example of an Angular component, or Angular 2 component. What's a good one? So I've also started getting into, kind of keeping my services shared away from my reusable code, or my components rather, and views is just essentially a distinction between a component and a component that has routable state. Essentially, they're kind of, they should be treated similarly, but generally, conceptually, we apply different intents, at least in communicating like the home page, the events page. And so to me, I found it's a little natural to distinguish those. You'll find that all of these are essentially mapped in my routes, my routes file for Angular 2. So, that's just a personal distinction that I like to make for myself. And then services are just, the services. Well, let's take a look at a component. So we'll take a look at post lists. So here, this is an example of ES6. This will be part of ES7. Yep. Oh, sure. Yeah, let's see what we got. Like that. Cool. So we have our imports here at the top. This is a generator. So this is using an ES7 feature that Typescript supports for us now. And we create our post list component class. We have our constructor, so that's where we pass in our post service. On init, we get posts, and then here's just a constant that I'm returning to say how many should display. So the thing that I like, especially about Angular and React and a lot of these ES6 flavored or favoring libraries is, short of this like ng init or the render function, there's really very little framework in your code, which is something else I really like. But you really only get that by using some of these newer frameworks that are built with the JavaScript language in mind, so you can take advantage of this syntax and basically define an entire component with just a couple, of properties. And you'll see here my styles URL, I'm loading in a less file, but Webpack's going to compile that into CSS either in memory for the dev task or to an actual file for the production task. Let me see if there's anything else worth sharing out of this. This was something else that I found really helpful. When setting up Karma, I was essentially able to pull in my entire Webpack config, so managing your files and all this stuff, with the exception of these couple that I haven't figured out why yet. Essentially, you have the entire config that you created for Webpack. You're basically able to reuse here, which helps minimize the amount of these dot file configuration files that you have in your project. So, and I have links for all these if you want to check them out. So just get to. We'll have questions in a second, but as with anything, there's always pros and cons. So, so of course, if you're not used to or don't already have a build process or a build step, that's pretty much the first thing that you'll have to learn. So with all the different tools out there, you'll kind of have to pick one. My preference, of course, is to pick something that's going to support all the ES6 features, be it your imports or your generators or whatever. TypeScript handles a lot of that for you. Webpack will later on. SystemJS with JSPM do all that together. So, there is that. A lot of us may already be using build steps, so adding something like Babel or TypeScript may not be that big of a deal, but it's still, it is a barrier to entry that should be recognized. So in certain cases, we were actually just having the talk, TypeScript, sometimes you like the dynamic flexibility of JavaScript. Well, I mean, you can use, TypeScript supports in any type. That said, I think just like when I started to see the benefit and value of unit testing, maybe I didn't like that I had to rewrite the thing I just spent the past week writing once I started trying to test it and realized that I can't even get my head around making this thing make sense and be reliable. And it just basically, helped me with my kind of design approach. And similar to TypeScript, when you really start committing to using types, it just adds maybe a little bit more discipline to the choices that you make. So to really get the most out of it, obviously it's not really helpful to just throw all over your application, right? As we were discussing, definitely with services, like that's really, really great to have an event service and an interface that goes with it. And anywhere that uses it, that you have a type to work against. So, I think it's just something to consider. It might, add some extra time on your your code reviews, but I think it'll be well worth the discussion in and of itself. One thing that might not be obvious from TypeScript, looking at it, is that it's only a compile time check. There's no guarantee at runtime that someone couldn't just from an external file try and dive into your class and try and start manipulating the properties or calling private functions. So there is that caveat, as we were just discussing, privates are not part of the ES6 specification, right? So those access modifiers don't exist in your actual code. Like once it turns into JavaScript, there's no private, it's not protected. So it is a compile time check, so just be aware that it's not, once you write in TypeScript, you're immune from any sort of external influence in the browser. So with SystemJS, Polyfill, another black box. So there's always that to consider. And just in general, initially the overhead and the tooling and the maintenance might seem a little daunting. So there is that kind of another barrier to entry, just being able to put it all together. All the options might seem daunting, and but I think it's well worth to make the investment now to align yourself with tools that will support your applications, I believe, for a lot longer than previous versions of JavaScript, and that's because things like import and classes and constructors really help to add clarity to the code, because the language actually supports constructs that we've all been trying to kind of duck type our way around or monkey patch before. And then the new language features like imports give you a lot of power when it comes to module bundling and module loading, lazy loading, all that stuff. So in addition to getting on the ES bandwagon and being there for the ride and attaching yourself to tools that are going to follow that ride along, I think you'll find that your code becomes a lot more readable, and as a result becomes a lot more maintainable. And for me, it's been a lot more fun to work with ES6 and TypeScript and all these. And I find that I've been writing code a lot faster, and especially getting that instant feedback from the TypeScript compiler is huge. So, so yeah. So any questions? I'm not sure how we're doing on time, if it matters, but yes.
So one thing we've struggled with at our company with all these tools is that you're trying to share like React components amongst different projects in the company.
Mm-hmm.
And the different projects that they've started at different times, one's built with Require.js, and one has built with Webpack, and maybe SystemJS. And so you start to get all these tool chains involved.
Mm-hmm.
And you struggle to figure out how to build a library so that they're consumable by all of these various tools. And so I'm wondering if you've had any Kenzan share like chunks of JavaScript, and if so, like do you have you blessed one or more of these as the one to use for like library building?
Right. So the Angular 2 project generates what's called a UMD, a universal module definition. So in the interest of code sharing, I haven't looked into it, but I would imagine that there are tools that you can provide a source file, JavaScript file, and it'll add like the necessary checks and fallback polyfills to allow your code to be shared, either in AMD require or common JS or imports. So I think that for the time being, if you're in an ecosystem where, like you said, you've got Webpack over here and something else over there, I think you'll best be served by generating a file that conforms to like the UMD spec, so that it can be consumed everywhere. That said, if you're going to go into React, that's kind of the ecosystem. That's fine. I don't think that every application you build might necessarily have to prescribe to the same tool chain per se. Depending on what the final motivation is for it. Like, say, an admin dashboard might not really need a whole Webpack build, right? You just might really just need SystemJS to just get that stuff in the browser because it's internal and private. But you still want your source code to be importable, right? You might have a production application that is using Webpack, but you're using 1.3, so you need require support, right? Well, if your file is in UMD, then you should be all set. So at the risk of prescribing a specific stack, I would just start with the source code and let that be flexible to support your different projects.
I think the next one,
Mm-hmm.
yeah, right now it's on the web component standard. We are in most browsers,
Mm-hmm.
mostly browsers that support web components in the future. Everybody else has the same problem as we say. So what we do, we usually wrap everything into the web component, and then we develop the development application to use those web components to build everything. So currently we are using Polyfill library.
Mm-hmm.
But they are also formulating all the specifications, and hopefully in the next 2 years we might have a common specification for the components. Because in HTML5 specifications already have the components there,
Mm-hmm.
but not all web browsers, specifically Internet Explorer, does not support it.
Right. And the actual, yeah.
But Polymer did a good job of developing polyfills for
Yep.
those non-supported.
And so Angular 2, yeah. Yeah, Angular 2 is also hedging their, leveraging web components where possible. So so Polymer is good, and so like, what was your name, by the way? Well, sorry, what was it again? Aditya?
Yeah.
Okay. So as he was pointing out, Aditya was pointing out, the web components specification is really like a combination of 4 or 5, like the templates and the custom elements, and there's at least 2 more. Shadow DOM is one, and then that's the 4th one. But imports, yep. So with that, so I mean, I think you'll find that a lot of, so right, in addition to, picking one that's going, JavaScript forward, a good point is, don't forget about HTML5. But I think you'll find that, Angular 2s and Reacts will, and, obviously Polymers, which is basically just an API around those specific specifications, making sure that they're leveraging web components where possible, right? So if the Shadow DOM is available, Angular is going to use that to scope your CSS to your specific custom element. So that's a good point to raise. So as you're working on these library projects for your organization, making sure that standards, that you follow standards is important too, and picking the tool chain that's going to support that now through polyfills, but also allow you to get rid of those polyfills over time. So can you just strip out, like in my SystemJS example, I could just whip out SystemJS at some point in the future, and that's it. Any other questions? Yes, in the back.
So where I work, we just started using the new class definition.
Yep.
There's a line that System 6. Now, we're trying to implement public-private methods.
Mm-hmm.
So we have this hack that we're using. I'm wondering if you've ever tried to do this.
Sorry, what was the?
You're public and private methods attached to a class.
Yep. So you're using the actual class,
Yes, we're using the actual class syntax,
but not TypeScript.
not TypeScript.
Okay. And so are you like defining the variable like outside and then just referencing it?
Our little polyfill that we're using is inside the constructor.
Mm-hmm.
We have just a named variable, which is not really tied to the class.
Oh,
So
okay.
we can't access it from outside.
Oh, that's interesting.
Then we have 2 functions called set and get, and then that refers to the functions that are tied to that object.
Mm-hmm. Yeah, I would like before ES6, I always did my classes with like a constructor function, and so that way I could always use vars, and then have actual. That's how I used to do privacy. I have nothing against Babel, but I think with what TypeScript gives you, and the fact that you could just write ES6 right out of the box, if you're interested in something that will provide that assurance for you, it's probably well worth looking into TypeScript. But yeah, I've been there as well, and yeah. But again, like that's I think the trade-off with using something like TypeScript is the actual build step. But now you've got one way.
We're already using Webpack.
Oh, okay. Nice. Yeah. Awesome. Yeah, I would check out TypeScript. It should be fairly easy to integrate with Webpack, and then you'll actually just have privates and publics, and you won't have to make sure you set up the ceremony of your. But we've all been there. So, but at least it's for me, I think that's just it's good to be thinking about that. Maybe it's not a library, but I still like to design it in a way that I kind of know what's going on. So I mean, it's good to have that in mind. And then if the language can actually give you the keywords to do it, then try and make the jump if you can. Yeah. Cool video. Oh yes.
So does TypeScript have any inbuilt functions to handle the multiple asynchronous calls? Like I have like 5 asynchronous calls and I want to execute them one after another.
Yeah, like async await.
Async
Async await. So that's ES7. I don't know if, I think they might have added support for that. I don't know if it was in TypeScript 2 or not. I think TypeScript 2, which is in beta, will have support for async await. But it does support like promises right now. That's its underlying mechanism. Awesome. Cool. Anybody else? So well, I think that's it. I just had just some links for us and list of references. So thank you.